Hello, in this video we're going to look at solving equations by regrouping like terms. So the way that I like to introduce the concept of like terms in algebra is to present the idea of being given a hand of cards. So if you were dealt the following hand of cards and they came out in this order, pretty much right away, if you were playing a game of gin rummy, for example, you would look at those cards and you would say, there's a way that I can organize them to make it easier for me to see what I'm dealing with by regrouping the cards that have similar suits. So I'm going to do that. I'm going to put all the diamonds together like this. And I can see I've also got a couple of spades. And I can see that I've got 2 clubs. And part of that process, for me, if I was playing this game, is also putting them in order. So I can see that I've got 2, 3. So if I was looking to make a straight or a sequence of cards, I would be able to see that I just need a 4 to continue that. When you're doing algebraic simplification and you're regrouping terms together, it's a good idea to put them in ascending order as well, just to keep things organized so you can see what you're dealing with. So I've really got 3 different groups of like terms in this scenario. I've got spades, I've got clubs, and I've got diamonds. But I also see that I've got a couple of 3s. So we'll see in a subsequent video an example of how that could come in handy. For the purposes of this video, I'm not going to be worried about that pair of 3s. I'm just going to be looking like this. So an example of an algebraic problem or an equation that requires regrouping like terms, kind of like my hand of cards there, is the following. (8n plus 5n equals 39). So this 8n and this 5n are kind of like 2 cards of the same suit. Okay, one of them, the coefficient or the value is 2 in this case, on an 8 here, and this one's a 5. The spade, or the character, is the n that they have in common, which makes them of the same suit. It makes them like terms. So in the same way that if I were looking at these 2 cards, I could say, well, together that's 5 spades. I can do the same thing with these 2 terms of 8n and 5n. I can put them together to make 13n. So I've just turned 2 terms into 1 term. At this point, if I wanted to isolate for the n and determine what the n is worth, I could divide by that 13. Just a reminder that in between a coefficient and a variable is a multiplication. So to isolate the variable or get rid of that 13, you're going to need to do the opposite of a multiplication, which is a division. So divide by 13 both sides, and you end up with n equals 3 for this sample problem. Okay, we're going to try another one. Second question. (9p minus 2p equals 35). So again, I have 2 terms that have the same variable, much like my 2 cards that have the same suit. Okay, different coefficients, different numerical values, same variable, same suit. So combine those 2 terms together. 9 minus 2 is 7. And now I'm going to eliminate the 7 by dividing it away. Just change color here. result is p on the left-hand side is equal to 5. So combining like terms in algebra is very useful for reducing the number of terms that you have in an equation. Do one more. Okay, so this time I've got 2 terms that have M and 2 terms that have S. This is like 2 cards of one suit, 2 cards of another suit. So I'm going to combine the M's together, and this M is the same as a 1M. You don't need to write the 1, but it can be helpful. So I'm going to make a little note here on the side that a variable like n is the same as 1n. Okay, so I've got 1m plus 1m. I can combine those together. That's 2 m's. And I've got 1s and minus 1s. I've not done anything to the right-hand side of this equation, so I'm going to leave it as 12. In this case, one of the terms with s is positive, the other one is negative, so they are actually going to nullify or eliminate each other, because 1 minus 1 is 0. So that leaves me with 2m's is equal to 12. And then between the 2 and the m, that's a coefficient, so that's a multiplier. Get rid of it by doing a division. And m is 6. All right, so next time you're dealing with an algebraic equation and you've been given a bunch of different terms of different types with different variables, consider thinking about this analogy and regroup those terms based on their variables, and then simplify by adding them together.